4.18. Quite a fascinating number with respect to liquid water, and this number is associated with a particular concept known as the specific heat capacity. And what does this mean? This means that it is the amount of energy in joules required to raise 1 kilogram of a sample of a something by 1 degree Celsius. And so this with respect to liquid water is really a big deal because yes, you will need that much energy compared to, let's say, ice water. How is that standard? And this here, according to here, it says that solid water value is around 2.11. That means that to raise the temperature of a solid water is much easier compared to that of liquid water. How about water vapor? That is even really lower, almost 0.11 difference between it and the solid water. But then if you look at other materials as the surroundings, when you are dealing with determining the amount of energy exchanging between the system and the surrounding particular type of material that is being used shows that the lower you get with that particular number, the much more easier you get that temperature to rise by. But then there is a caveat here. The caveat is when you get to a particular material, let's say lead's value is 0.13. That number is really small. It's really easy to raise the temperature of lead. Lead, of course, is a huge conductor of heat. However, we know that lead is not really appropriate when it comes to the use in the lab. Quite expensive, not really accessible compared to that of liquid water, and also in terms of how toxic it can be when it is let out there. So pretty much that makes sense why we don't use lead at all. There's copper, there's iron, all those numbers are less than 1 for the specific heat capacity. Even when you're doing an aqueous reaction, it's really nice to have liquid water to dissolve your salts, and then mixing your salts together, that gives you a nice access to how much energy is going to be released or absorbed during that particular double displacement reaction. So pretty much makes sense when liquid water is used compared to, of course, lead, which is not really soluble in some salts, majority of salts, I assume. So pretty much interesting to see why we use water, liquid water, as the right surroundings for your bomb, or let's say your cup calorimeter